Perfect. Okay, so we are going to have a test today. It's got 20 questions. I told you every single question on the test on Tuesday. The good news is, even if this is the most disastrous math test you've ever taken, when you leave here today at 1:30 or whatever time you finish your test, you don't have to think about this class until I see you on Tuesday. It's been a super intense start. I think we've been in class about 2 weeks, or has it been 3 weeks? 3 weeks? So when you leave today, at least you got the weekend to regroup, okay? You don't need to do anything this weekend, nothing. We're going to take the test, and when you finish the test, you can leave whatever time that is. We're not going to start the test, though, till about 12, and then that gives you an hour and a half. But before we take the test, I want to start with this, because there's a couple of these on the test, and then I'm going to go to the yellow packet and answer any questions that you had over the 48-hour period before you saw me today. And then, like I said, I want to start the test at about 12. That gives you plenty of time. I'm going to let you use your yellow notes pack and this sheet. I decided to let you use the yellow note pack, not the yellow note pack you just touched. Yeah, no, the yellow one, yeah. Not because I think it's really going to do you any good, but maybe it'll give you some type of comfort to know that you can look at your factoring notes if you need to, or look at your radical notes or whatever. I don't really think you need it, but you can use it. Sometimes people just, it helps their mind to know that they can have something to look back at. But let's review what we did on Tuesday. So these are called, oh, I didn't give you all paper, I'm sorry. These are rational exponents. I got quite a few people out, and I only have one of them.
I thought that was
Okay, that's fine. Don't worry about it. I just thought it was next. All right, so this worksheet right here is rational exponents. You saw some of this on your yellow review guide, but we can talk about that too if you want to. But rational exponents means that you have a fraction, because all of the exponents that we had done up to this particular problem were integers. Raised to the second, raised to the fourth, raised to the negative third even. We've done some of that. But we hadn't had fractional exponents. Now, I am warning you that you have to show some work on the test on this problem. And I've got that written on the test. You can type this in your calculator and press enter. Yes, you can. But you're not going to get credit, because I said on the test you got to show me how you got this, because we need to practice what this means. Everybody can type on a calculator. That's not what we're here to learn. We're here to learn the math behind that stuff. So we talked about your top number is your power and the bottom number is your root. Justice told us you can remember that by thinking about the plant grows on top and the roots are in the bottom. I like that. And so what this is asking us to do is to take the square root. The bottom number is the root. In other words, the number in the crack. So we are taking the square root of 1 over 25, and then we are raising that to the power of 3. Now, am I correct, Tom, that we did version A?
Yeah.
Okay, so this is a different version. So on your test, you're going to have to show me that step right there. In other words, on the test, I want to know if you know what raising something to the 3/2 really means. Not, can you type 3 divided by 2 in your calculator? Now, if you want to use your calculator to figure out the square root, but I'm going to use my sheet just because I want to practice the sheet. The squares are under the squared column. So here's 1. We know, and you can use this on the test too. The square root of 1, go to the left, is 1. So the square root of 1 is just 1. We know that. And the same thing for 25. Find 25, go over to the left. So the square root of 25 is 5. And then all of that needs to be cubed. In other words, 1 times 1 times 1. You can use this sheet for that as well. So if you want to know what 1 to the 3rd power is, it's 1. And if you want to know what 5 to the 3rd power is, it is 125. So the answer is 1 over 125. That is the power over the root. And we use this in a lot of different topics in this class. Okay, it's not just today's test and we're never going to see it again. We're going to use this on multiple things that we do in here. All right, y'all try number 3. It's exactly like number 1. So try number 3. It's almost exactly the same. All right, the answer to number 2 is 1 over 27. It's almost exactly the same as number 1. I've got that worked out up here. If you did not get that, you can look at it. But does anybody have any questions on 1 or 2? There's only one of these on the test, but actually, not exactly true, but there's one just like this on the test. There's a couple more that ask power over root. All right, the difference between 1 and 2 and 3 and 4 is that you have a negative. But let's slide up, or let me slide up, and let's look at 3 and 4. So on number 3, you have the negative in front of 32. And on number 4, you have the negative on the 1/2. Now, Kayla, is 3 or 4 the issue? Which one has a problem?
3.
Because this is a negative on a what? Exponent. This is a no, okay? This number 4 is a no, because we learned a long time ago you can't have a negative exponent. This is not a negative exponent. This is a negative coefficient, and there's nothing wrong with that. So we're going to have to do some work on 4, but 3 is okay. So we'll just do 3 exactly like we did 1 and 2, okay? So the power is squared. The root is 5th. So we're going to take, I'm going to have to write a little bit smaller, the 5th root of negative 32, and then we want to square whatever we get. Again, the root goes in the crack, so we're talking 5th root, and your power goes up here at the top. All right, negatives are just like positives. You can take, we learned this, we wrote this down. You can take the odd root of a negative. If you don't know how to do that, since it's 5th root, go to your 5th column, here it is, find 32, and then go all the way to the left, and the answer is 2. But if this was a negative 32, what kind of 2 is it going to be? Negative. It's going to be a negative 2. So it's going to be, I'm running out of room, it's going to be negative 2 squared, and a negative times a negative is a positive 4. So the answer to number 3 is positive 4. Now, like Kayla said, if you look at 3 and 4, there's nothing wrong with 3. Yes?
I thought a negative inside of a square root was an imaginary number.
That's true. A negative in front of a square root, a negative inside of a square root is an imaginary number, but this is not a square root.
Oh,
You can take the odd root of a negative. Third root, fifth root, seventh root, 11th root, 13th root, 17th root. But you cannot take the square root or fourth root or sixth root. And it would be an imaginary number, which is the first thing we're going to do when I see you on Tuesday. But you can take the odd root of a negative. Okay, good question. That's not going to trip you up on the test, what he just asked. But yeah. You can't take the square root of a negative. That's true. But this wasn't a square root. This was a fifth root. But the problem down here is that you cannot have, you got a question, Nathan?
Yeah, I was just wondering, so I mean, I got that, but how would you know to put parentheses around your 2 when you do the -2 to the power? Because if you didn't, it would change it to -4.
Well, that's true. But you see how this -32 was in parentheses and everything in this parentheses was raised to that power? So everything in this parentheses has to be raised to the second. So everything in this parentheses has to be raised to the 2. So if every one of these problems was given parentheses to you. If I had not, that would have been an issue, but I got it in parentheses, so I'm covered. All right, so go back. It's been a few weeks since we've studied monomials. What do I do to take care of this issue? Move it to the bottom. That is correct. Now be careful here. What I'm going to do is flip it. I'm going to put 81 on the top and 25 on the bottom. I'm going to flip this, okay? Oh, sorry. Thank you. All right, so to take care of this issue, I'm going to do what's called flip it, okay? So 25 goes on the top, 81 goes on the bottom. I'm going to flip it, and when I do that, this becomes positive 1/2. When I make that flip, 81 to the top, 25 to the bottom. They're changing locations. Yes?
Don't you just want to flip the exponent?
No, you don't ever flip the exponent. No. The exponent stays the same. It's just going to change signs. So he's talking about flipping this. This is not what flips. It's the coefficient or your base that flips. This is still a 1/2. It just comes down here and becomes a positive. All right, so our power is 1. That's easy. Our root is 2. So what this is asking us to do is, and I'm going to put it in parentheses, Nathan just asked that question, take the square root of 81 over 25 and then raise it to the power of 1. Square root of 81 over 25. All right, what is the square root of 81? 9, and the square root of 25 is 5. So 9 over 5 is the answer. Now, let's talk about this. I didn't talk about this on page A, but turn your paper sideways and let's talk about this. This is not something that's getting ready to, I'm not going to ask you this on this test, but this is something moving forward that you need to start having an understanding of. So, raising something to the 1/2 power, which we just did on example 4. We raised that to the 1/2 power. So, if you look at your work and what we did there, raising something to the 1/2 power is the same as taking the what? Square root. You got to have that square word though, because it's not the same as the cube root. It's not the same as the fourth root. But raising something to the 1/2 power is the same as taking the square root. Yes?
I have a question on number 4.
Okay.
So what I did was I did 1 over the square root of 25.
That's fine. And then you have to flip that.
And then I got 1 over 5 divided by 9.
You have to simplify that. That is a complex rational. In other words, you've got double fractions on that 1 over, and you've got to keep, change, flip. I don't know if you remember that term from middle school when you have 2 fractions that are divided. Keep the first fraction, change the division to multiplication, and flip the last one, and you'll end up where we are. You can do that. It's just a little bit of an extra step. But you cannot stop. He's saying right here he ended up with 1 over 5/9. So if you end up with 1 over 5/9, this is called a compound or a complex fraction. You can't keep that. You'd have to do keep, change, flip. And so you keep your 1, you change this to multiplication, you flip your bottom fraction. 1 times 9 is 9, 1 times 5 is 5. You get the same thing we got. That's fine. I didn't do that because I knew it would be an extra step. Okay, let's look at our sheet. Yes?
It's kind of a similar question, but I did it. Does it matter what order you did it in? I mean, for this one, I did the square root of 25 over 81, so you get 5 over 9. the -1, which is just the inverse of 9/5.
That's fine. Yeah. Let me see your sheet, Tom. Let me hold A from Tuesday. A, yep, right there. All right, we didn't talk about this on Tuesday, so let's talk about this answer on Tuesday because somebody kind of just referred to this. So these are our papers from this pink one we just did. This is version B. But the one that we did in class on Tuesday was version A. We did not talk about this question, but this kind of relates to what Justice and Mario just said. So raising something to the 1/2 power is the same as taking the square root. So what do you think raising something to the 1/3 power is the same as? Cube root. And you could go on and on and on. Raising something to the 1/4, is the same as the 4th root. Raising something to the 1/7 is the same as the 7th root. What you want to start recognizing, and it doesn't have to be today, but you want to start recognizing that if you get a problem that's written as a radical square root and you don't like that, you can just rewrite it as power of 1/2, and vice versa. If you get a problem that's written to the power of 1/2 and you don't like that, you can just change it to square root. Raising something to the 1/2 and square rooting are the same. Raising something to the 1/3 and cube rooting are the same. Again, you do not need to know this today, but as we do more of this, you're going to start seeing, I prefer 1/3 and 1/2, and Tom prefers square roots and cube roots, and we can interchange those. And you'll see later on in this course, sometimes you're given a problem with a 1/2 exponent, and we don't want to deal with that, so we go to a radical. They're interchangeable. Okay, let's look at the yellow. Now, I'm not talking about you that had to stay after for some factor remediation. I mean, I can ask questions on that one too. But I'm talking about the classic yellow packet that we've been using since we got here. Let me find mine. All right. Let's start with the review at the back. I told you to complete H1 through H4. The odd are at the back. I'm going to grade the even, but before I grade it, I'm going to answer any questions that you have. So looking at the even problems of pages H1 through H4, does anybody have one they want me to do? Yes. Number 2. All right, let's look at number 2. Let's look at number 2. Okay, this 4 needs to be distributed to this 4, to this A, and to this B. Now remember, this right here, this is a coefficient. This is not an exponent. So 4 to the power of 4 is the same thing 4 to the power of 4 was in the creation of time, which is, where did I put my purple paper? Where's my purple paper? There it is. All right, you can use your power sheet, or you can use your calculator, or you can use your own common sense. But 4 to the 4th is 256. So that's going to give me a 256 right there. Now, as a little reminder, we're going to follow PEMDAS for the exponents. What am I talking about? Please excuse my dear Aunt Sally. All right, what that means is this is an exponent. That 4 is an exponent. And we learned from PEMDAS that you have an exponent, you actually jump back one operation and you're going to multiply. So these little exponents, this 2 and this 1, which you can't really see, and this 4 are going to be multiplied together. So A2 times 4 is A to the 8th. B1 times 4 is B to the 4th. So that's how you simplify that first term. Now, you've got a good bit of work left to do here, so I'm not finished, but that's how you simplify the first term. Okay, we're going to do the same thing for the next set of parentheses. I need to square this negative. I need to square this A. I need to square this 2. And I need to square this B. Now, this is just a -1. Even if you can't see it, there's a -1 in front of that A. And I need to square all 4 of those terms. So what's a negative 1 times a negative 1? Positive 1. I'm not even going to write that down. It's just a placeholder. All right, we just learned a couple of seconds ago that this is an exponent. So actually what we're going to be doing is multiplying this 1 and this 2 and multiplying this 1 and that 2. That's what we're going to do for the exponents. So 1 times 2 is a2. It's not a cubed. Down here, 2 is a coefficient, and your coefficients do not change. 2 squared since the beginning of time was 4, and it's still 4. So put a 4 down there, and then 1 times 2 gives me b squared. Now, if you want to, like if you just don't like the way that that looks because you've got a whole number integer on the left and a fraction on the right, you can put a 1 under this just to kind of make them look like top, top, bottom, bottom. But what we're going to do next, and there's a couple of different ways to combine this. Let's combine everything on the top, and then we'll worry about everything on the bottom. So it's going to be 256. All right, how many A's do I have up top? 10. Because remember the rule up here at PEMDAS, if you're asked to multiply, you're really going to add. So right here where we're asked to multiply, it's really going to be adding. And then we have 4b, so it's b to the 4th. And then I'm going to do the same thing. I'm going to combine my bottoms. Like I said, just the 1's a placeholder. 1 times 4b squared is 4b squared. Sorry. Let me zoom out a little bit. Now, let me say this in terms of the test. I, as old as I am, and as many times as I've taught this class, it's now going to be, let's see, 10 times 2 is 21 semesters, and I've never not had a semester without Math 171. So that's a lot of times I've taught this class. I cannot do that in my head. I also would not have to show every single step that I'm putting down here. So somewhere between 1 step and 4 steps is where y'all need to land on the work for the answer, okay? I could probably start with my problem 1 step and get my answer. So that would be 1 step. But it might take 3 or 4, and that's fine. All right, now I'm just going to clean it up a little bit. What's 256 divided by 4? Okay, and it's going to be on the top because 64 is bigger than 4, so 64 on the top. There's 10 A's on the top. I can't do anything with that. And then now we use our division rule. Go back up here, and it says if you're dividing, you actually subtract the exponents. So what's 4 minus 2? 2, and they should be up top because there were more up top. So the answer is 64, a to the 10th, b squared. Now let's look at where that is on the test. So that's number 5 on the test. Number 5 on the test is a moment. I'm not saying it's that hard. It's actually easier than that, but it's the concepts.
Could you not also use GCF just from the original simplification? A GCF of 4, 52 would get you the same answer.
Okay. Did you write that down? Because I'm not quite. Let me see. I mean, if you got the same answer, that's fine. But I've never mixed factoring with monomials, so I don't know how that would work out. I think you're referring to reducing.
So when I did that,
Hold on, wait. All right, so you did that, and then you did what? You said they both have a 4b squared.
Yep, that was my answer.
Okay, so this is not GCF because remember GCF is take it out, put it out, and bring your leftovers down. So if it was GCF, this is what you would have. But what you can call that, this is a reduction. You reduced, which is fine, by 4b squared. That's why the 4b squared vanished. Because if it was a GCF, it would have to go out here in the front. Okay, so you did it correctly. You just used the wrong word. It's a reduction. You reduced by 4b squared. Yes, that's fine. All right, I want to go down to number 8. Whether you have a question or not, I want to look at it because I know this is on the test, and this is something that it's a little bit different than what we talked about. It's power over root, but you just might not have recognized it. So your power is 2, your power is 5, and your root is 3. So what they're asking you to do is rewrite using only exponents. Now, technically, it would have helped if this had said rational or fractional exponents, but you might not have known what they were talking about. This is exactly what I was saying. Some people, this is easy for them. Some people would be better off with fractions, and that's just a personal preference. So another way to say this, also known as, would be x to the 2/3 and y to the 5/3. That's another way to write that problem using rational exponents. Those two things are equal. They're not opposites, they're equal.
So if you run it like this, that's still good, right? It's the same thing, it's just a different form.
No, it says using exponents. You don't have any exponents. You got a radical. No, it needs to have rational exponents.
What about if we do x to the 2/3 and e to the 5/3? Is that fine?
Oh, yeah, I'm sorry. That's my fault, Cam. Yeah, that's a P. Sorry. This is a P. P. Sorry. But you have to get rid of the radical. That's the whole point. Either you have radicals or you have rationals, but you don't, a radical, if you still got a radical in your answer, then you didn't go to rationals. Okay? What? Number 4, definitely going to be on the test. 32, and it's talking about the 4th root. The best thing to do here is to go to your 4th root column and start closest to 32. So we'll just start at 81. No, that will not go. Back it up, 16. Will 16, and sometimes you just have to test it with your calculator. The other day, these guys were working, I was like, just test it, put it in and see if it works. Will 16 go into 32? Yes, it will, 2 times. So what I'm going to do is I'm going to break this up to the 4th root of 16 and the 4th root of 2. Let's take care of that before I do the 9 and the 7. All right, we know, looking at our paper, that the 4th root of 16 is 2. So a 2 is going to get out, and a 4 is going to get stuck. I do know that. Yeah, sorry. 2 is going to be stuck. I said it wrong, but I wrote it right. Thank you. So 2 gets out, 2 gets stuck, and it's the 4th root. Do not make it square root. You changed the problem right there. Now, let me give you a warning, because you're going to use this several times on the test. Okay, several times on the test. You're going to take your power, and divide it by your root, which is 4. This is old school division. This is not put 9 divided by 4 in your calculator. This is old school where you have remainders. All right, Ethan, how many times does 4 go into 9 evenly? 2 with a remainder of what? 1. Because 2 times 4 is 8, and you need 9, so you've got a remainder of 1. All right, Ethan, how many times does 4 go into 7? 1 with a remainder of 3. Now, your whole number gets out. So for my x's, I've got 2 out, and for my y's, I've got 1 out. Let's go ahead and put those out. So x squared gets out, and y1 gets out. And then whatever my remainder is gets stuck. So 1x gets stuck, and 3 y's get stuck. So stuck in the radical is 1x and 3 y's. Now, that, I'm not going to do 6, but there are several times on the test that you're going to use that concept right there. Mm-hmm.
That was 2. Yeah. I got over 16 4.
Oh, yeah, that's right. This is a 4. This is a 4, sorry. No, I was right. The 4th root of 16, I was right. That's why nobody stopped me. The 4th root of 16 is 2.
So after you break it down, you bring down the 4.
It's asking for the fourth root of 16, not the square root of 16. What number 4 times gives you 16?
What number 4 times? Okay, yeah. Right. Correct.
I'll come look at your paper, but let me get my white out because now I've messed it up twice. Hold on.
Right.
Hope nobody watches these videos because they'll be like, that lady's whack. Okay, let's go back to the top on that one. We broke 32 because I went to my sheet and I'm on the fourth root column and I see that it's 16 times 2. So I broke 32 down to the fourth root of 16 and the fourth root of 2. Well, what is the fourth root of 16? 2. You got me?
Didn't bring that 4 down.
What 4?
The fourth root.
Oh, you didn't bring the fourth root down. Okay, right.
I got
Okay.
everything else right.
Right, but that's a good point, Justice. If you don't bring the fourth root down, you're going to think it's the square root of 16, which is 4. So then you're going to be confused because you changed your problem. All right, let's go to the next page because we've got about 12 minutes before I want to start. 10 or 12? I'm not going to do both of them, but I'll do one of them. 10. All right, 10. 10 is radical 2a plus radical 18a. They are not like terms. Okay, they are not like terms. They both have an a, but one has a 2 under the radical and the other one has an 18 under the radical. So I can't combine them right now, definitely on the test. But what I can do is break this down. This is the square root of 9 times the square root of 2. Now, I'm going to keep this one as is right there because I can't do anything to that. All right, but 18, don't do 6 and 3. Do not do 6 and 3 because 6 nor 3 are perfect squares. And if you do 6 and 3, you might not realize that something comes out of that 18. But if you go to your perfect square of 9, you'll say, all right, square root of 9 times the square root of 2 is 18. The square root of 9 is 3, and that's going to leave me with a 2a under the radical.
So why don't we bring that 2a straight down like that?
Why not? Well, how would you get it out? Can you take the square root of 2? No, 1 times 1 is 1. So let me get my calculator.
No, I'm talking about the first 2a.
Because I can't do anything with that. I cannot take the square root of 2. I cannot take the square root of a. So I'm just writing it down just for kind of notation more than anything else. And then that's the same reason here. This 2 cannot do anything, so I bring it down. And this a cannot do anything, so I bring it down. Now things are looking good. These both have a 2a, so these are like terms, and I can combine them. Even if you don't see it, there's a 1 in front of here. So, and if you say this, I mean, don't start talking to yourself in the test, but if you listen to me say this makes sense. 1 radical 2a plus 3 radical 2a is 5 radicals 2a. I mean, that just makes sense when you say it. These are like terms. So 1 radical 2a and 3 radical 2a is 5 radical 2a. 4. Oh, Lord, please help me today. I'm not doing good, and these people are going to be confused. I'm sorry. I cut the tip. Can y'all see this? I cut the tip of my finger off last night. I'm so distraught. My husband bought some new knives on Amazon, which we did not need. He's like, I got you some new knives. I was making a salad. I didn't even feel it. I mean, I was like this, and I cut the tip. It was blood everywhere, and the knife was so sharp, I did not even feel it. And I looked down, and I cut the tip. That's why this is jacked up bandage, because it won't, a real Band-Aid. I had to put a pad there with pressure, and then I had a rubber band around it. It's doing okay today. But I cut the tip of my finger off last night. I don't know why, if that's why I'm so discombobulated or some other things happened today. But yeah, I cut the tip, I cut the tip of that finger off right there. I was so aggravated. I was aggravated with myself, but I thought about this though. Knives scare me. I don't like knives. And I never understood how you could stab a person. Because in my mind, like, it would be hard for me to get a knife to go through a person. Well, I learned yesterday that if you get you a sharp knife, you can stab a person. I saw that yesterday. I didn't understand that because I don't really have sharp knives at home, but these things are crazy sharp. And I was like, yep, this is how you kill people. Okay, Kim, yes.
So you just do the 1 plus a 3, and that's where do you get a 1 from?
There's just a 1 in front of that. Even if you can't see it, there's a 1.
Yes, ma'am.
And that goes back to PEMDAS. Remember when we did the PEMDAS model? Let me write that up here. Please excuse my dear Aunt Sally. When you add or subtract, what did we say you do to the exponents? Nothing. Same thing is true for radicals. When you add a 2a and a 2a and a 2a, it stays a 2a. Now, kind of back to what Cam just asked. All right, Cam, if I just tell you this is a, what's in front of that a, even if you can't see it? 1. And what's the exponent on that a, even if you can't see it? No, it's just a 1 if you can't see anything. So these are understood to be there. They're just understood. All right, I'm skipping 13, 15, because they were odd, and I told you not to do 14. So let's go to, what time is it? Oof, that clock is wrong. Number what? 18. All right, I'm going to make a box here just because if you're not great at math, I think the box is a really good strategy to use. So this is just a FOIL problem. 5x plus 2, and then negative 3x plus 7. And I'm just going to fill out the little parts of my box. So 5x times negative 3x is negative 15x squared. Negative 3x times 2 is negative 6x. 7 times 5x is 35x. And 7 times 2 is 14. I like the box method. Like I said, if you're not great at this, this is a good strategy because usually your like terms are going to be right there along the diagonal, and they are. So the answer is going to be negative 15x squared. What's that, 29x? Plus 14. All right, 20, 22, and 20. Oh, let's look at 24 just for kicks. I know you probably got this correct, but why is 24 prime? It's not a GCF. It's not a grouping. It's not a trinomial. It's not a breakup story. It's not a difference or sum of cubes. Why? That's exactly right, because it's got that plus right there. Now, if it was a subtraction, it would have been the difference of perfect squares, but it's an addition. All right, last page. We maybe got time for one more. Let me look at these. Nah, let's stop. All right, let's take a short break. Go stretch your legs, take a few deep breaths, say a prayer, get a tissue or whatever you need to do, and we'll take our test. Y'all need to spread out, one person per table. You can, 2 people can sit, but just not side by side. And you can use your yellow packet and your your power sheet. You can use both of those things on your test. Nope. Hold on just one second. Let me stop this session.